Hello students, welcome back to your favorite YouTube channel, Tomachang Tutorial. Myself Kishan Kulung, and today we are here to discuss about Gay-Lussac Law. Let us first read the statement of the law and then we will understand, okay? Gay-Lussac Law. When gases combine to form gaseous chemical compound or compounds, the volume of the reacting gases and those of the products are in the ratio of small whole numbers, measured under the same condition of temperature and pressure. This is Gay-Lussac's law of gas. Okay, it is very simple. Let me explain. When gases react, they react so in volume also. When gases react, they react so in volume also, and the ratio of the volumes of reacting gases and the product, if the product is gas, the ratio of the volumes of reacting gases and the product, if the product is gases, are in the ratio of small whole numbers. Okay, suppose, let me give you an example to make you understand this better. Hydrogen gas reacts with chlorine gas. Okay, hydrogen gas reacts with chlorine gas to produce HCl gas. I am just giving an example. Hydrogen gas reacts with chlorine gas to produce HCl gas. Let us first balance this chemical equation. If I write 2 here, the equation will be balanced. Hydrogen reacts with chlorine to produce 2HCl. Okay, from here, if there is no number, we should understand there is 1 in front of H. Okay, 1 volume of hydrogen reacts with 1 volume of chlorine to produce 2 volume of hydrochloric acid or HCl gas. 1 volume of hydrogen reacts with 1 volume of chlorine gas to produce 2 volumes of hydrochloric gas, HCl gas. Okay, the volumes are in the ratio of small whole numbers. These are whole numbers, 1:1:2. Okay, this is what Gay-Lussac's law tells us. It's very simple. Okay, so if we move further by applying Avogadro's law, what does this mean? If n molecules, okay, suppose if V volume of S2 reacts with V volume of Cl, V volume of hydrogen gas reacts with V volume of chlorine gas, then 2V volume of HCl gas is produced. If V volume of hydrogen gas reacts with V volume of chlorine gas, then 2V volume of 2V, okay, this is 2V volume of hydrochloric HCl gas is produced, or hydrochloric acid is produced. Okay, now suppose n molecules of S2 reacts with n molecules of chlorine, then 2n molecules of HCl gas is produced. N molecules of hydrogen reacts with n molecules of chlorine to produce 2n molecules of HCl. That means 1 molecule, okay, half molecule. This is not Gay-Lussac's law. I am just elaborating it with Avogadro's law. Okay, this is not Gay-Lussac's law. I am just elaborating. Gay-Lussac's law is this much only. Half molecule of hydrogen reacts with half molecule of chlorine to produce 1 molecule of HCl. Okay, if we write HCl without any number in the front, HCl, that means one molecule of HCl. We understand one molecule of HCl. Then what happens? Half molecule of hydrogen combines with half molecule of chlorine to produce one molecule of hydrochloric acid or HCl gas. According to Dalton's atomic theory, atoms are indivisible. Atoms cannot be divided further. So molecules can be divided. So from this we can understand half molecule of hydrogen means one atom of hydrogen reacts with one atom of chlorine gas to produce one molecule of HCl gas. This is the equation I related with the Avogadro's law. Avogadro's law tells us if the volumes of gases are equal, the number of molecules should be also equal. So half molecule, volume, so one molecule, okay? Half molecule adds up to become one molecule. This is Avogadro's law. I'm just relating with the Avogadro's law. Let us forget about Avogadro's law and Dalton's atomic theory right now. Let us come back to our main topic. Our main topic is when gases react, they do so in volume and the ratio of the volumes will be in small whole numbers. Okay, this is the simple thing. Suppose, for example, if I write 30 ml of hydrogen, I have 30 ml of hydrogen. How much hydrochloric acid gas, HCl gas, will be produced? If I have 30 ml of hydrogen gas, then how much HCl gas will be produced? Okay, if this is the question, how will I find? Since one volume of hydrogen produces two volumes of HCl gas. One volume of hydrogen produces two volumes of HCl gas, isn't it? So 30 ml will produce how much? 60 ml, isn't it? One volume of hydrogen produces two volumes of HCl gas. That means 30 ml of hydrogen gas produces into two times, that is 60 ml. So how much chlorine will be required if the question is asked? Then since one volume of hydrogen requires one volume of chlorine, you can see one in the front of chlorine, one volume, one in front of hydrogen. One volume of hydrogen requires one volume of chlorine to produce two volumes of HCl. So one volume of hydrogen requires one volume of chlorine, means 30 ml of hydrogen will require 30 ml of chlorine. Got this? Now let us do some numerical problems to understand this law better. Okay, let us solve this numerical problem to understand Gay-Lussac's law better, okay? But before solving this question, I would like to let you know that Gay-Lussac's law is applicable only for gases, okay? Only for gases. Gay-Lussac's law is applicable only for gases. Gay-Lussac's law is inapplicable for solid and liquid. Volume of solid and liquid should be considered zero. What is? Volume of solid and liquid should be considered zero. Gay-Lussac's law is applicable only for the volumes of gases. Got this point? I'm erasing this. Now we will further solve this question and understand the concept of Gay-Lussac's law. Okay? Let us first read out the question. Calculate the volume of oxygen and STP required for the complete combustion of 100 liters of carbon monoxide at the same temperature and pressure. Okay, at the same temperature. Okay, this is the equation of combustion. Carbon monoxide Oh, this is carbon dioxide. No, I'm writing carbon monoxide. Carbon monoxide burns in oxygen to produce carbon dioxide gas. We know that carbon monoxide burns in presence of oxygen to produce carbon dioxide gas. Let us balance this equation. We have oxygen 2 here, oxygen 2 here, and here 1. This is not balanced, so let us put 2 here and 2 here. Now it is balanced. 2 carbon, oxygen 2 plus 2, 4, and oxygen 2 to the 4. Oxygen is also balanced. The equation is balanced. Now you can see 2 volumes. Let me explain this in brief. 2 volumes of carbon monoxide reacts with 1 volume of oxygen to produce 2 volumes of carbon dioxide gas. So the question is 100 liters of carbon monoxide. If 100 liters of carbon monoxide is taken, then what volume of oxygen is required at STP? Find the volume of oxygen. Find the volume of oxygen at STP required for the complete combustion of 100 liters of carbon monoxide. The question is very, very simple. What amount of oxygen is required, or what volume of oxygen is required for the complete combustion of 100 liters of oxygen? 100 liters of carbon monoxide. Let us understand. 2 volumes of carbon monoxide require 1 volume of oxygen, isn't it? There is 1 in front of oxygen, there is 2 in front of carbon monoxide. So 2 volumes of carbon monoxide require 1 volume of oxygen. That means 100 liters, L-I-T-R-E-S, liters, okay, this is liters. 100 liters of carbon monoxide will require just half, because 2 requires 1 volume, 100 requires 50 liters. The question is solved. It is very, very easy, isn't it? But we must solve this in method, okay, in a process. This is very, very simple. Okay, let me solve. Since 2 volumes, this is the way how we solve, okay. 2 volumes of carbon monoxide requires 1 volume of O2. We can see from the equation 2 volumes of carbon monoxide require 1 volume. There is 1 in front of O2. 1 volume of O2. 2 volumes of carbon monoxide require 1 volume of O2. 2 volumes of carbon monoxide requires 1 volume of O2. That means you can write 1 volume, unitary method. 1 volume of carbon monoxide requires 1 upon this 2 comes down. 1 upon 2 volume of O2, isn't it? So 100 liters of carbon monoxide require how much O2? 100 liters, now the volume is 100 liters, okay? 100 liters of CO requires 1 upon 2 into 100, isn't it? Volume or liters of O2. 2 1s are 2, 2 5s are 10, 2 0s are 0, equal to 50 liters. This is as simple as that. Actually, answer you can just see and find out the answer by yourself. 2 volume require 1 volume, 100 liter require 50, isn't it? But you need to solve this by this method, okay? Let us do another question and understand this in a better way. Solve another numerical question to understand Gay-Lussac's law better. Let me read out the question. 200 cm cube of hydrogen and 150 cm cube of oxygen are mixed and ignited. What volume of oxygen remains unreacted? Okay, this is the question. We have 200 cm cube of hydrogen and 150 cm cube of oxygen. Both are mixed and ignited. Now the chemical reaction occurs and how much oxygen is left unreacted? That is the question. Let me solve this, okay? Let us first write the chemical reaction. Hydrogen reacts with oxygen to produce water, H2O, or water vapor, you can see. Let me balance this chemical equation. We have oxygen 2 and oxygen 1, so you need to write 2 here. Hydrogen 4, so you need to write 2 here. Now the equation is balanced. 4 hydrogen, 2 oxygen, 2 oxygen. Okay, equation is balanced. Now, from this balanced equation, first of all our duty is to balance the chemical equation. Now, when the equation is balanced, we can see 2. There is 2 in front of hydrogen. So, and there is 1 in front of oxygen. So, 2 volumes of hydrogen require 1 volume of oxygen. 2 volumes of hydrogen require 1 volume of oxygen for complete combustion, isn't it? 2 volumes of hydrogen require 1 volume of oxygen for complete combustion. But we are provided with 200 cm cube of hydrogen and 150 cm cube of oxygen. Now let us say 2 volumes of hydrogen require 1 volume of oxygen. If we have 200 cm cube of oxygen, then how much? If we have 200 cm cube of hydrogen, then how much oxygen will be required? 2 requires 1, means 200 cm cube of hydrogen requires 100 cm cube of oxygen. But we have 150 cm cube of oxygen. That means how much oxygen is left unreacted? Very simple, 50. So the answer can be just seen at and can be said easily. But we have to solve this by a method. And let me solve this, okay? Since 2 volumes of hydrogen requires 1 volume of oxygen. You can see we don't need water. Forget about water. Water is not asked in the question, so we don't talk about water. 2 volumes of hydrogen require 1 volume of oxygen. We wrote that 2 volumes of hydrogen requires 1 volume of oxygen. So 1 volume, if 20 apples cost rupees 50, then 1 apple, if 20 apples cost rupees 60, then 1 apple cost rupees 60 upon this 20. This is unitary method 3. If the cost of 20 apple is 60, cost of 1 apple will be 3. This is unitary method, very simple. If you know the cost of 1, then you can find the cost of many, isn't it? The simple thing. 2 volumes of hydrogen requires 1 volume of O2. So 1 volume of S2 requires, this one remains here, this 2 comes down, 1 volume of O2. Got this point? If 2 volumes of S2 require 1 volume of O2, then 1 volume of S2 require 1 upon this 2 volume of O2. Then, therefore, how much? 200 cm cube, isn't it? 200 cm cube, volume is 200 cm cube. 200 cm cube of hydrogen requires 1 by 2 into 200 cm cube of O2. This is how much? 2 ones are 2, 2 ones are 2, 2 zeros is 0. 100 cm cube of O2. But we have 150 cm cube. Please take the screenshot of this. I'm going to erase the upper part. Okay. But we have 150 cm cube of oxygen. So how much oxygen is left unreacted? But we have 150 cm cube of oxygen. Therefore, 150 minus this much oxygen is reacted, isn't it? 100 equals to 50 cm cube of oxygen is left unreacted. Okay, this is very simple. The ratios of the volume 2:1, that is what Gay-Lussac Law tells us. Okay, now we will do another question to understand again. Okay students, let us do another numerical question to understand Gay-Lussac Law better. Okay, the more question you do, the more numerical problems you solve, the better you understand the law. Let us read out the question. What volume of oxygen would we require to burn completely 400 ml of acetylene. Also calculate the volume of carbon dioxide formed. Okay, this is the question. Let me write the chemical equation first and then we will understand. Acetylene gas, C2H2. The formula for acetylene is C2H2. Acetylene. Acetylene burns in oxygen to produce carbon dioxide and water. Okay, acetylene burns in oxygen to produce carbon dioxide and water. Now let us balance the chemical equation. 2, 5, this is 4. Okay, this is 4 and this is 2. Now it is balanced. 4C2, 4C, hydrogen 4, hydrogen 4, oxygen 10 from the 8 to 10. Okay, this is the balanced chemical equation. Now we have 2 in front of acetylene, 5 in front of oxygen and 4 in front of carbon dioxide, and this is water. So water is liquid, isn't it? And in Gay-Lussac's law, the volume of liquid should be considered 0. So we should not apply the volume of water here. We forget water. Okay, we forget water. Now let us read out the question. What volume of oxygen would be required to burn completely 400 ml of acetylene? 400 ml of acetylene is given to us and volume of oxygen is asked. Okay, since two volumes of acetylene requires 5 volumes of oxygen and produces 4 volumes of carbon dioxide. 4 volumes of carbon dioxide. See here. Forget about water. 2 volumes of acetylene requires 5 volumes of oxygen for complete combustion to produce 4 volumes of carbon dioxide. Okay, 2 volumes of acetylene requires 5 volumes of oxygen for complete combustion to produce 4 volumes of carbon dioxide. Okay, we got this. Now first let us find the value of oxygen or the volume of oxygen first. What volume of oxygen would be required to burn completely 400 ml of acetylene? How much ml of acetylene is given? 400. And we are asked to find the volume of oxygen required, isn't it? Since 2 volumes of acetylene requires 5 volumes of O2. Got this? So apply unitary method. 1 volume of acetylene requires 5 upon 2 comes down 2 volumes of O2, isn't it? So we have 400 ml. So 400 ml of acetylene requires 5 upon 2 into 400 ml of O2. 2 1 is 2, 2 2 is 4, 2 0 is 0. So 5 2 is 10, 5 2 is 10 and 2 zeros ml of O2. Okay. If 400 ml of acetylene is to be burned completely, then 1000 ml of oxygen will be required. Since 2 volumes of acetylene requires 5 volume of oxygen to burn completely, so 400 ml of acetylene requires 1000 ml of oxygen to burn completely. This is the first answer. We are asked to find the volume of oxygen first. Okay. Now the second part of the question. Also calculate the volume of the carbon dioxide formed. We are asked to find the volume of carbon dioxide also. Please take the screenshot of this. I am going to erase this. Okay. Now we are asked to find the volume of carbon dioxide produced. Okay. Now here, Since two volumes of C2H2 यानी कि or I mean acetylene, two volumes of acetylene produces four volumes of CO2. You can see 4 in front of carbon dioxide, 4 volumes. 2 volumes of acetylene produces 4 volumes of CO2. I wrote this from here. 2 volumes of acetylene produces 4 volumes of CO2. That means apply unitary method. 1 volume of acetylene produces 4 upon this 2 volumes of CO2. Therefore, we have how much? 400 ml of acetylene. So, 400 ml of acetylene produces 4 upon 2 into this 400 ml of CO2. 2 1s are 2, 2 2s are 4, 2 4s are 8, 2 4s are 8, 2 zeros ml of CO2. We have found out since 2 volumes of acetylene produces 4 volumes of carbon dioxide, then how much carbon dioxide will be formed when 400 ml of acetylene was burnt in oxygen? When 400 ml of oxygen was burnt in oxygen, 800 ml of carbon dioxide was produced. This is the answer, and I hope you understood the concept which I wanted to teach you from Gay-Lussac's law. Thank you so much for watching my video, and I hope you will subscribe and click the bell icon to get notifications for more videos like this. Thank you.